Hey guys, so I made some errors when I was working through this with you in class last time, and I'm so sorry about that. I would like for you to be able to see a corrected version of what we had done, and I've tried a couple of times now to get this video to cooperate with me, and I'm still struggling. So hopefully this version will work. It's already written in here, but I'll just guide you through what I've done. So we're going to take a look at the second derivative, and this is actually something the last book that I taught out of, which was 4 years ago, didn't actually even have in it, or if it did, I guess maybe it wasn't a portion of what we had done in class. So it's been a really long time, and I just went off my gut of what I remembered, and I didn't remember correctly. So the moral of the story is make sure to check your stuff before you assume that you remember right. So the second derivative you'll see on the bottom of the screen down here, and the second derivative of y with respect to x twice is actually defined in parametric form to be d dt of the dy dx, which is what you have already found. At least in most cases. And then with respect to x, again, would be dx dt in the denominator. So you can see as we move along to the right-hand side, this would be the way that we're thinking about it. So we have our first derivative here where we did y prime over x prime. We take the derivative of that with respect to t. So that actually should say dt here. Let me fix that. Yeah. And then dx dt on bottom. So we had two examples where we did second derivatives, so I'm just going to show you the version of that cleaned up. Neither one's super clean because we have derivatives of quotients in there oftentimes when we're cleaning this particular process up. So this one is our example number 2. So with example number 2, we had second derivative of y with respect to x twice. And here was our dy dx that we had from before. So as we're looking at this, we have the quotient rule here on the right. So we have the denominator times the derivative of the numerator plus the numerator times the derivative of the denominator divided by the denominator twice, right? The second derivative of the denominator. And looks like I might have missed a coefficient of my denominator here in a moment. Yeah, I won't change anything because I've got zeros and ones, but yeah, okay, so, and then I have this denominator that's in yellow right here, flipped upside down, so multiplied by the reciprocal. So I should have had here a 2. So there's a 2 sort of missing from right here. I'll write it in front with my negative. So here's that negative 2 from the denominator that's in yellow. So simplified, I have, this is the denominator here. Use a different color so I can draw your attention to it. This is this denominator squared right here. And then the other piece of the denominator is coming from the flip upside down of this piece right here. The green is not showing up very well. Let me see if I try a different color. That might work a little bit better. So this piece right here is coming from here. So that's the reciprocal. If we clean up the numerator a little bit, I have 8 sine 2t sine 4t minus 4 cosine 2t cosine 4t, and the denominator ends up being negative 2, if I can put that 2 in there, and then sine cubed of 2t. Unfortunately, because I've got different angles inside, and I've got sines, and I've got cosines, it's kind of just a big giant mess. But thankfully, we're just asked to evaluate this at pi over 4. So when I plug in pi over 4 to sine 2t, it becomes pi over 2. Sine of 4t, that becomes a pi, and so forth as we work our way through. And the ones that are highlighted in yellow right here that you see, those are both 0. So the entire numerator is 0. The entire denominator is actually a constant, which is good because that means I don't need like L'Hopital's rule or anything. I just have 0 as my derivative value. And in terms of my graph, that means it's a place where the concavity is at least potentially changing, or it's flattened out. So we have a changing concavity at that point. And so the other one that we had here was actually example 5, and that's this one. So we had gotten on example 5 to this point last time, or at least I shouldn't say it that way actually. What we had done is we had done this piece, and then we went on to second derivatives incorrectly. So if I did actually finish a first derivative, I would have this piece over here simplified. So I have 2t minus 1 over 2t plus 1. And then using that second derivative form that we discussed on the other screen, I would need the derivative of the 2t minus 1 over 2t plus 1, which is a quotient rule, denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. And then this denominator over here, we have 2 plus 1 over, 1 over t. And if I simplify that, that's actually 2t plus 1 over t, which I can flip upside down in terms of a fraction to t over 2t plus 1. With a little bit of cleanup from the numerator, I end up with just a 4 on top times the t that's from my yellow piece over there, so that's 4t. And the denominator is 2t plus 1 cubed. If this equals 0 or it equals does not exist, right? So if, in other words, if the numerator equals 0 or the denominator equals 0, I have places where I at least have a potential concavity change. So my numerator equals 0 at 0, and my denominator equals 0 at negative 1/2. And if I set up a sign chart over here with those two values, those three intervals, I can test locations and test a value in each location. So if I test a value before negative 1/2, I actually end up getting a negative in the numerator and a negative in the denominator, which is a positive overall. If I test a value between negative 1/2 and 0, I still get the negative in the numerator, but the denominator is now positive because I have 3 positive values all multiplied. So negative over a positive is a negative. And if I test a value bigger than 0, then the numerator and the denominator are both positive, so I get a positive. So in terms of my concavity, I have negative infinity to negative 1/2, and 0 to infinity are concave up. And then from negative 1/2 to 0 is concave down. So what I will do in terms of your WebAssign is that as soon as I get this posted here, I'm going to go in, I'm going to adjust your WebAssign to be due tomorrow instead of today. You know what, we'll just make it Wednesday because that'll make it easier, so that's always at class time. So we'll say it's due at Wednesday at class time. It should just be a couple of them that you go through and have to adjust, and I'll see if I can catch them and add a number of tries to them. I'm not sure how to do that, but I'll try. And then also in class today, you won't turn this assignment in. You'll have the opportunity to take a little bit more time to fix it, and so that we can turn it in on Wednesday. Thanks so much, guys.